Yeah, good evening, children. So it's a new chapter today, perimeter and area, right? Let's recall some terms from class 5 and class 6. Answer these. Give a special name to the following triangles. Give a special name. This is 3, this is 5, and this is 6. 3 centimeters, 5 centimeters, 6 centimeters. How are triangles classified based on sides? Based on the length of the sides. Scaling. So classification of triangles based on the lengths of their sides will be scaling triangle where no sides are equal, isosceles triangles where isosceles triangle where two sides are equal, and equilateral triangle where all the three sides are equal. And how are triangles classified based on their angles? We classify triangle under two headings: based on angles, based on sides. Based on sides, scalene, isosceles, equilateral. No sides equal, two sides equal, three sides equal. Based on angles, if all the angles are acute, it's an acute angled triangle. If one angle is a right angle, it's a right angled triangle. And if one angle is obtuse, it's an obtuse angled triangle. If all the angles are acute, all the angles are acute, it's an acute angled triangle. If one angle is right, meaning if one angle is a right angle, one angle of the triangle measures 90 degrees, then it is a right angled triangle. And if one angle of the triangle measures more than 90 degrees, but less than 180, obtuse angle. So if one angle of the triangle is an obtuse angle, then the triangle is called an obtuse angled triangle. So these are the terms we use to classify triangles based on their angles. Acute angled triangle, right angled triangle, obtuse angled triangle. Now here, what's marked? If the sides are marked, you must give a name based on the sides. If you know the angles, then based on angles. But if you see a combination, if you can see the length of the sides and the measures of the angles, then you can use both the terms. Like if you see one angle of the triangle marked 90 degrees, and you also see that two sides are marked equal. When two sides are marked equal, isosceles. If one angle is 90 degrees, it is right. Then that triangle is an isosceles right triangle or right isosceles triangle. Put both together. It's a right triangle because one angle is 90 degrees, and it's isosceles because two sides are equal. So put them together, right isosceles triangle. Yeah. So in the first figure, none of the sides are equal. So scalene triangle. Next one. Two sides are equal. 8, 8. This is 5. So isosceles triangle. Isosceles triangle. Equilateral. Yeah, here you can see all the three sides are marked equal. So equilateral triangle. Equilateral. Equilateral meaning sides are equal. Tell me a quadrilateral which is equilateral. Equilateral means sides. Equi meaning equal. Equi meaning equal. Lateral is sides. Equilateral meaning equal sides. Now my question is, yeah, a square is a quadrilateral, which a square is an equilateral quadrilateral. A square is an equilateral quadrilateral. Because in a square, all the sides are equal. A rectangle is not an equilateral quadrilateral because only opposite sides are equal. Yeah. Next one, see here. Can you see this angle marked? What does this symbol indicate? 90 degrees. 90 degrees. When it's marked like this, it's 90 degrees. And what do you see here? 5 centimeters, 5 centimeters. These two sides are equal. So it is a right isosceles triangle. Right because one angle is 90 degrees and isosceles because two sides are equal. Right isosceles triangle. All right. And this one? Right angled triangle. Right angled. Right angled triangle. Here. So you do not have any information about the sides. You only have information about the angles. So you'll have to name this triangle based on the angles. You cannot, just because it looks like a scalene triangle, all the sides are different, you cannot say it's scalene. Just by looking at it, you get a feeling that it should be a scalene triangle. No. You must have information. Using that information, you should name the triangle, not just by the way the triangle looks. It looks like a scalene triangle. No, no. So here we don't have information about the sides. So you cannot name this triangle based on sides. You have to use a right triangle or acute angle triangle or obtuse angle triangle. Yes. Name. Acute angle triangle. Think again. When do we call a triangle an acute angled triangle? No. You should, like get the complete definition in your mind. What is an acute angled triangle? Yeah.
When the angles of the triangle are less than 90 degrees, it's called an acute triangle.
Yeah. When all the angles of the triangle measure less than 90 degrees, it's an acute angular triangle. Yeah. Now check on all the angles. What's the measure of this angle? What's the measure? This is 60 degrees. This is 20 degrees. What's the measure of this angle? 80 degrees. Is it 80? How is it 80? What is the sum of all the three angles of a triangle? 180 degrees. 180. The sum of all the three angles of a triangle is equal to 180 degrees. So 180 minus 60 plus 20. So 180 minus 80, 100 degrees. The measure of this angle is 100 degrees. And what is an obtuse triangle? A triangle in which one angle is an obtuse angle, is an obtuse angled triangle. So this one is an obtuse triangle. You can say obtuse triangle or obtuse angled triangle. So actually we were given only these two angles, 60 degrees and 20 degrees. Now when you have to give this name to a triangle, acute angled triangle, you must make sure that all the three angles are acute, not only two or not only the given angles. If you have to call a triangle an acute angled triangle, all the three angles must be acute. All the three should be acute. 60 is acute, okay? 20 is acute. What about this? You should find. Otherwise, you cannot name it as an acute angle triangle when you didn't check on the third angle. So this one is 100 degrees. It's not acute. Then this is not an acute angle triangle. So one angle is obtuse. So it's an obtuse angled triangle. All right? Yeah. So this one is an obtuse angled triangle. What about this? 65, 30. 65 and 30 degrees. Much? 85. 85 degrees. So what do you call this triangle? All the angles are acute, so it's an acute angled triangle. All the angles measure less than 90 degrees. So it's an acute angled triangle. What about this? This is 60 degrees. This is 60 degrees. And this one will be 60. Yeah. You can call it an acute angled triangle, or when all the three angles are equal, all the three sides also will be equal. Equilateral triangle. So this angle, though we do not know anything about the sides, we don't know anything about the sides. But in a triangle where all the angles are equal, all the sides will be equal. Whether it is equal to 5 centimeters, 6 centimeters, 10 centimeters, we don't know. But all the three sides will be equal. So you can call this triangle an equilateral triangle or acute angled triangle. Acute angle triangle. Next one.
Right hand.
90 degrees. So
Right hand.
right angled triangle. But what will be the measure of this angle? What will be the measure of this angle? 45 degrees. Now in a triangle, when two angles are equal, the sides opposite to them also will be equal. Now which is the side opposite to 45 degrees? This one. The side opposite to this angle 45 degrees, this one. In a triangle, when two angles are equal, the sides opposite to them also will be equal. The side opposite to this angle, this is 45 degrees. Opposite to this angle is this side. Opposite to this angle is this side. 45 degrees, 45 degrees. The side opposite to this angle is this side. Opposite to this angle is this side. So these two sides are equal. These two sides are equal. So you can call this a right isosceles triangle. Right isosceles triangle. Because one angle is a right angle, and when you use the angle sum property and find the third angle, that also measures 45 degrees. So we see that in this triangle, two angles are equal. When two angles are equal, two sides are equal. Which two sides? The sides opposite to the equal angles. Opposite to this angle, this side, and opposite to this angle, this side. These two sides will be equal. So it's a right isosceles triangle. And the last one, you can see, now you can see the triangle. It's an obtuse angled triangle. See, this is 90 degrees, right? This is 90 degrees. So it's more than 90 degrees. This angle, see, this is 90. This is more than 90. This will be 90. This is more than 90, right? So it's an obtuse angled triangle. All right. Leave some place to complete this. I'll send these images. You can do it in your classwork later. Okay. So you know how much to leave. We'll have to draw the figure. We'll have to draw the figures and write the names of the triangles alongside. Okay. Okay. So the first plane figure we are going to see in this chapter is a parallelogram. Okay. So in a parallelogram, opposite sides are equal. In a parallelogram, opposite sides are equal. The difference between a parallelogram and a rectangle is that in a rectangle, the corner angles are right angles. In a rectangle also, opposite sides are equal, right? In a parallelogram, opposite sides are equal. Opposite sides are equal. This side is equal to this side. This side is equal to this side. But in a parallelogram, these angles will not be right angles here. These are not 90 degrees. But in a rectangle also opposite sides are equal. But the corner angles are 90 degrees, right? So what's the property of a parallelogram? In a parallelogram, opposite sides are equal. Like a rectangle, opposite sides are equal. Angles are not right angles. Only opposite sides are equal. There are many more properties. I'm just telling you what is needed for your standard 7 standard. Okay. So area of the parallelogram is given by the formula base into corresponding altitude. Base into corresponding altitude or base into height sometimes. They just say base into height. Height, altitude both mean the same. Height, altitude both mean the same. Base into corresponding height or base into height. But height is the corresponding height. Should be the corresponding height. Now, what is that corresponding height? Okay. So when you take this as the base, okay, which is the base? Any side of the parallelogram can be taken as the base. Now, a parallelogram is a quadrilateral. It has 4 sides, right? Any side of the parallelogram can be taken as the base. Base is not only this. Base is not only this. You can take any of the 4 sides as the base. Okay, so if you take this as the base, the altitude should land on this base. So see here, altitude on this base. This is the altitude on this base. If you take this as the base, you must take the altitude on that base. If you take this side as the base, then this will be the altitude on that base. If you take this as the base, then this is the altitude on that base. Sometimes the altitude will lie outside the parallelogram also. We'll see such figures later. Altitudes can also lie outside the parallelogram. So when we say corresponding altitude or corresponding height, the altitude should land on that base. Whichever side you're taking as the base, the altitude should land on that base. So here, if you take this side 4 centimeters as the base, then you can see the altitude. It's landing on 4 centimeters. No, so that's the corresponding altitude. All right. Don't work anything now. So what do you say? Area of parallelogram is equal to base into height. So base is 4 into height 3, 12 centimeters square. Correct? Correct? Directly you're going to, like solve some questions by yourself. After discussing, I'll give you a set of questions. You can do them by yourself. Simple, right? Yeah. You can see here. This side is 4 centimeters. So we have to take this side as the base. And you can see the altitude landing on that base. Can you see? This is the altitude that lands on that base. If you take this as the base, the altitude should land on that base. See here? If supposing this is given, supposing this altitude is given as, say, some 3 centimeters. Okay, you should not do this. You must not say area of parallelogram is equal to base 4 centimeters into altitude 3. No. When you're taking this side as the base, you cannot take this as the altitude because this altitude lands on this side. This altitude lands. Okay, it falls on this side. If you take this side as the base, then you can take this as the altitude. But this is not given, right? This base is not given. The length of the side is not given. So you cannot take 3 as the base. Sorry, 3 as the altitude. What is given to you? This side, 4 centimeters. So you have to take this side as the base, right? So then which is the altitude? This is the altitude, right? Okay. So here, what should you write? You need to find the value of x. Area is given to you. Area is given. When area is given, you should start working like this. Area is equal to 24. When you have to find area, you must write area is equal to base into height. You should write the formula. When you have to find area, write the formula like this. Area is equal to base into height. Then substitute the values 5 into 4, 20, whatever, meters square like this. But if area is given, you write like this. Area is equal to 24 centimeters square. Now below area, base into height is equal to 24. Understand? Below area, you must write base into height is equal to 24 because area is base into height is equal to 24. Okay? When area is given, what you should do? You must write that area is equal to 24. Area means base into height is equal to 24. Base is 4. Height is x is equal to 24. X is equal to 24 by 4, which is 6. 6 centimeters. Okay? If you have to find area, you must write area is equal to base into height and substitute for B and H and get the value for area. If area is given, write area is equal to that value, whatever is given. Then below that, you should write base into height is equal to whatever here, 24. Okay. So what do you see here? Look at the figure because you have the diagram. You can follow from this itself. So the length of the side AD is given. Okay. So if you take 4 centimeters as the base, then which is the altitude? X is the altitude. This is the altitude. If you take DC as the base, then 3 centimeters is the altitude. See, you cannot take 4 centimeters as the base and 3 centimeters as the altitude. Which is the base? Any side can be taken as the base. Which is the base? Any side can be taken as the base. But altitude, whichever side you're taking as the base, the altitude should land on that side. So supposing you take 4 centimeters as the base, you should not take 3 centimeters as the altitude because that's not the corresponding altitude. So if you want to find area, if you want to take 3 centimeters as the altitude, you must take 6 centimeters as the base. Is that part clear? Okay, I'll not be repeating this. Okay. So the first subdivision is to find the area of the parallelogram. So if you take 4 centimeters as the base, you don't know the altitude. So you should not take 4 as the base. Where do you know the base and the corresponding altitude? 6 and 3. Okay. You can take even 4 centimeters as the base, but you don't know the corresponding altitude. So don't take that because you'll have to find area. To find area, you should know both base and height. You have to find area, right? So area is equal to base into height. You should know base, you should know the altitude. So you should take 6 as the base. And the corresponding altitude is 3, 18 centimeters square. Now, right, area is equal to 18. Base into height is equal to 18. See, for the same figure, whichever base and altitude you take, the area should be the same, no? Area cannot change for the same figure, for one figure. Now, if you take 4 centimeters as the base and x as the altitude, you should get the same area, 18. The same figure, no? So area is equal to 18. Base into height is equal to 18. So you are taking which one is the base? AD is the base and x as the altitude, correct? Or you can directly write 4. Which one are you taking as the base? 4 is the base. X is the altitude is equal to 18. So x is equal to 18 by 4. On cancelling, you get 9 by 2 or 4.5. 4.5 centimeters. Two questions you have to answer. One is area of the parallelogram. For that, you should take the values where you know base and the corresponding altitude. So you should take 6 and 3 only. So you got area. Now you have to find the height corresponding to, you'll have to find the height. Please see the screen. No, you'll have to find the height corresponding to the base AD. You'll have to find the height corresponding to the base AD. This is the base AD, height corresponding to that base. So you should find X. So for that you should write, so second sub question is not to find area because we already found it in the first sub question. So in the second one you should write area is equal to 18, base into height is equal to 18, base is 4, into height is x is equal to 18. So x is equal to 18 by 4, which is 9 by 2 or 4. This is difficult. You want to note down this because I'll be giving you questions like this later. Are they still working with the first exercise or moved on to the second one? Finished the first one? Sixth sum. Okay. Find the area of the following triangles. So you can see here in the second figure, this is the triangle L, M, and this is the triangle. This is the triangle. Okay. Now the altitude to this side Mn, see this is the altitude. This one is the altitude. This one is the altitude to the side Mn, but it will meet the side when it's produced. This is the side produced. See, this is not the triangle. Don't get confused. This is not the triangle. The dotted lines are outside the triangle. LMN is the triangle. LMN, this is the triangle. Then what is this? This is the altitude, LO. Okay, altitude to which side? To the opposite side, NM. But where it's not meeting that side. No, yeah, it's meeting when it's produced. Altitudes can also lie outside the triangle. Okay, there's an obtuse triangle. It's an obtuse triangle. In an acute triangle, all the altitudes will lie inside. I'll tell you these details later. I have this. I don't want to do it today. See, here I have it. Okay, talking about the altitudes here. See, altitudes of a scalene triangle. All of them will lie inside. You can see the three altitudes. In a right triangle, I'll tell you. So these are the altitudes of a right triangle, and here the altitudes of an obtuse triangle. We'll discuss them later. So I'm not saying much about the altitudes now. For now, you just understand that LO is the altitude to the side NM, but it doesn't meet NM. It meets NM produced at O. Okay. So if you take MN as the base, then the corresponding altitude is 2. Because this one is not landing on NM, but it lands on NM produced. No. See, where does this altitude land? Where does it land? It's landing somewhere outside the triangle. But when you produce a side NM, when you produce it, it lands on NM produced, right? So that's the altitude for NM, the side NM. Okay. So for the first triangle, now what we saw earlier, parallelogram, area, base into height. Triangle, area, half base into height. Triangle, area is equal to half into base into height. Okay. So half into base 4 into corresponding altitude. Can you see the altitude PS 2 centimeters? It is falling on 4 centimeters base. Corresponding altitude. Okay. So half into base 4 into altitude 2. Correct? For the next one, half into base. For a triangle also, you can take any of the three sides as the base. Any side, in any figure, base is any of the sides. Okay, you take, this is the base. So the corresponding altitude is 2. So then you just cancel like this and 3 centimeters square is the area. All right? Half into base into height. Correct? You were a little late, but you didn't miss anything of this. Okay, you just watched the recording for the first 10 minutes. Yeah. So here also, when they, give you area, when you have to find area, you should write area is equal to half into base into height. When they give, area, then you should start like this. Area is equal to 36. Half into base into height is equal to 36. Why I'm writing half into base into height? Because it's triangle, not parallelogram. Okay. They've given, can you see that area of the triangle is 36 centimeters square. So area is equal to 36. Below area formula, half into base into height is equal to 36. Half into base they want you to find. On which side is the altitude landing? On which side is the altitude landing? BC. BC. So we should take BC as the base. Then the altitude is 3. Correct? And that's only the question. See here. Find BC. Find BC is a question. Find BC is a question. All right? Yeah. So half into Actually, see, I wrote like this. Half into, which is the altitude here? 3 centimeters, right? And that altitude lands on which side? BC. BC, we don't know the length, so I'm just writing BC. Half into base BC into 3 is equal to 36. So now BC is equal to, now this is 3 by 2, no? It's 3 by 2. So it will become 2 by 3 on the other side. This is 3. 3 is in the numerator. 2 is in the denominator. It's 3 by 2. It will become 2 by 3 on the other side. Like this 2 will come here and this 3 will come down. The 2 is in the denominator here. No, it will come to the numerator on the other side. 3 is in the numerator here. So it will come to the denominator on the other side. They'll take opposite positions. This 3 is in the numerator. See, it's in the denominator here. 2 is in the denominator. See, it's in the numerator here. Cancel and get the answer. All right. So it'll be 3, 12 times. So 12 to the 24. All right. I'm not reading the question because it's all in the figure. What is in the figure is given in the question there. So what do you see? Name the triangle. Dotted lines are outside the triangle. So name the triangle. PQR. The triangle is PQR. You're not able to read that, Tanya? Yeah. Yeah, name the triangle. PQR. How many altitudes are known? Meaning how many altitudes are drawn here? 2. Name the altitudes. QM and PL. QM and PL. Now, QM is an altitude to which side? PR. QM is an altitude because QM, where does it land? Which side does it touch? PR. PR. Now, does the altitude PL touch any side? No, it doesn't touch any side, but it touches a side produced. Which is that? Huh? QR produce பண்ணா இப்படியாக்கும் போகும், இப்படி போகும். RQ, you must say. There's a difference between saying QR and RQ. எந்த directionல produce ஆகுதோ அப்படி சொல்லணும் பேரு. So this is RQ produced, not QR produced. QR produced means QR produced, it will go like that. RQ produced, RQ produced like this. Okay, we'll see again. Name the triangle. PQR. How many altitudes are given? 2. Name the altitudes. PL and QM. QM is an altitude to which side? PR. PL does not land on any side. It's outside the triangle. But it lands on which side produced? RQ produced. So if you take RQ as the base, which one will you take as the altitude? PL is the altitude. Okay. So all that's what is given in the question. Now we have to answer 2 things. Find the area of the triangle PQ. Okay. Now, if you take 8 centimeters as the base, do you know the altitude on it? You can see the altitude QM, but do you know the length of QM? If you take PR as the base to find the area of this triangle, if you take PR as the base, you should take QM as the altitude. Base is what? Any side you can take as the base, but you should know the corresponding altitude. So you can take 8 centimeters as the base, but do you know the length of QM? No. Then you cannot find the area using PR into QM. Half into PR into QM, you cannot do. Correct? So Tanya, silence is because you're following well or you're confused with something? Yeah. With what? Oh, okay. So you're able to understand, but not able to like name the sides. Correct? Is that
Actually, the question is speaking about.
okay? Should I repeat the questions?
No,
Now it's fine, huh? Okay. No, I can come again because when I put you with a set of questions, you shouldn't. I want all of you to do it correctly. Yeah, I'll pause here. You
no,
okay? Okay. Okay. Name the sides of this triangle. Name the sides of this triangle. PQ. Name the three sides of this triangle. Sides are line segments. How do you name a line segment? Using two capital letters. PQ, RQ.
Q.
QM is not a side of the triangle. The triangle is PQR. The triangle is PQR. Name the three sides of this triangle. PQ, QR, PR, or RP. You can say PQ or QP. You can say PQ or QP. QR or RQ. Both are the same. You can say PR or RP. Both are the same. So this is how you name the three sides of the triangle. PQ or QP, QR or RQ, RP or PR. These are the three sides of the triangle. Okay. Now name the three sides of this triangle. PQ, RQ, PQ, QP, both are the same. No, go in one direction. Why that confusion? See here, go in a direction. PQ, QR, RP. That's all. Name the three sides of this triangle. PQ, QR, RP. Okay. All right. Now name the altitudes drawn here in this triangle shown in the figure. Name the two altitudes shown in this figure. Yeah, Danya. PL, QM. These are the two altitudes. Tanya, sure? You need to be expressive, Tanya. You're caught somewhere, some mental block. Release that. You can ask me. Which one? Okay. Okay, relax. You look a little nervous actually because you're not falling. So looking a little, meaning you're feeling nervous. It's okay. No, I'll just stop 1 minute. Discuss with your friends. I'll just come back in 5 minutes. You just talk to your friends and you have your textbook, right? Yeah, see the same, see all these questions in your textbook. Just discuss and I'll come back in 5 minutes. I don't want to proceed.
Tanya was behind.
Okay. So back to this question. Triangle is PQR, altitudes PL and QM. QM is the altitude on the side PR, and PL is the altitude on the side RQ produced. The first sub question is to find the area of the triangle. So you need to take up the base whose altitude is known. Okay. You should know both the things. So area is equal to half into, you can take the base as QR or RQ into the altitude that falls on RQ produced, PL, right? So half into RQ is 4 into PL is 5. See, if you take area is equal to half into, if you take PR is a side, no? Any side you can take as a base, PR into QM, half into, PR is 8, QM, we don't know. Then how will you find area? So we can't do this. So area is equal to 10 centimeters square. Now we'll have to find QM. We'll have to find QM. For that, what you need to do is area is equal to 10 because it's of the same triangle. So the area will be 10. Area for the second sub question, area is equal to 10 centimeters square. Half into base into height is equal to 10. Half into, take PR as the base, into height, corresponding height, QM is equal to 10, right? So half into 8 into QM is equal to 10. So 2 ones are 2 fours are. So QM is equal to 10 divided by 4, correct? Correct? 10 by 4, which is 5 by 2 or 2.5. All right? All these are parallelograms. So base into height, base into corresponding height, base into corresponding height, base into corresponding height, base into corresponding height. You can see the altitudes fall on that side. Okay, so in all these figures, you're given the length of one side and its corresponding altitude. So base into height will give you the area of the parallelogram. These are triangles. Half base into height, half into base into height, half into base into, see, the altitude, it lands on that base. So half into 5 into 3.2. Now in this triangle, this is a right triangle. So in a right triangle, if you take this is the base, this is the corresponding altitude because these two sides make 90 degrees, right? The angle between these two sides is 90 degrees. So if you take this as the base, this is the altitude. If you take this as the base, this is the altitude because those two sides are at right angles to each other. If you take this side as the base, this is the altitude. If you take this side as the base, then this is the altitude. In a right triangle, leave the hypotenuse. This is the hypotenuse, right? There's a side opposite of the right angle, which is the hypotenuse. The side which is opposite of the right angle, that's a hypotenuse. And leave that side. The remaining two sides, if you take one of them as the base, the other one is the height. If you take this as the base, then this is the height. All right? So half into, if you take 3 as the base, then height is 4. If you take 4 as the base, then height is 3. Then here, This is an obtuse triangle. Okay, so this is the triangle. So this side is 3 centimeters. It's not marked correctly. It should come here. Okay, this side is 3 centimeters. And the altitude to that side, see, it doesn't fall on that side, but it falls on that side produced. So if you take 3 as the base, 2 is the altitude. Half into 3 into 2. Okay. So here you have to complete the table. Very simple. Everywhere the area is given, right? Everywhere the area is given. So how should you? Whenever area is given, you should start like this. First one, area is equal to 246. Area is given, so area is equal to 246. And in all the 4 cases, they're parallelogram. So base into height is equal to 246. Now in the first one, what is given? Base is given, so 20. Into height, you have to find is equal to 246. Plug this and find the height. That's answer for the first one, correct? Second one. What's area? Area is equal to 154.5. Correct? Next, base into height is equal to 154.5. Base we don't know. We have to fill. Into height is how much? 15 is equal to 154.5. Next step, base is equal to 154.5 divided by 15. Correct? So same thing as well. Yeah.
And in our class, they did like 152 by 10.
Huh?
154 multiplied by 10.
Yeah, you can do that. Yes, that's what you have to do next. See. Base into 15. Okay, here itself we can do that. Even I've done the same thing. Base into, I just left it to you. That's all. I didn't say. See it. See it. 150. Can you see it here? That's what you said, right? Yeah, yeah. I didn't mention that because I wanted you to think and calculate correctly. That's how you're supposed to work. So base into height is 15 is equal to 1545 by 10. Okay. So base is equal to 1545 by 10. Where is 15 here in the numerator? So it will come to the denominator. Cancel and get the answer. You know what? Sorry? Okay, we are multiplying 154.5, no? Multiply and divide by 10. Okay, when you multiply and divide by 10, what will happen? 154.5 into 10 is 1545 by 10.
In our class, they taught directly what you have to into 10 into 10.
Yeah, that's what even I have done. Like I multiplied the 10 and I wrote the answer that by 10 I put here. I'm not showing that into 10. See, I'm not showing that into 10. Into 10 I already did. 154.5 into 10 is what? 1545. Then by 10 I've put it here. By 10. You're right, the same thing. Here what you should do, no, don't disturb the 10. Cancel only this and this. Okay, so supposing you get some 103 by 10. So it's 10.3. Don't disturb 10, 100,000 in the denominator. Cancel the remaining numbers. Then it's easy not to divide by 10, 100. Just place a decimal point. So the last one also, see, area is equal to 16.38. Base into height is equal to 16.38. Base is 15.6 into height is equal to 16.38. So what you can do is, this is into 10 by 10, right? So into 10, when you do, you get this by 10 into h is equal to 1638 into 100. Into 100, you'll get this by 100. So H is equal to 1638 by 100. This 156 by 10 becomes 10 by 156 here. Now cancel. Is this what you were saying? Yeah. Okay. Till the 6th one, your teacher's finished, right? Okay. Look at this one. SR is 12. SR, this one is 12. QM is 7.6. That's marked. Okay. Okay. The other things are known. Which is the altitude on SR? Which is the altitude on SR? QM. Which is the altitude on PS? QN. Yeah, correct. Now, where do you know both the base and altitude values? SR and QM. So how will you find the area? Using SR as the base and QM as the height. Yeah, now you know the area, right? Okay. So I'll just take some random number. Supposing you got area is equal to 80. Supposing you got 80. Okay. Area is equal to 80 you got from the first one. Now you should find QN if PS is 6. If PS is 6. If PS is 8, sorry, should find QN. Find QN if PS is 8. Find QN if PS is 8. So PS is 8, right? Should find QN. You now found area. In the first question, you found area. Area is 80, for example. So base into height. Base into height is equal to 80. What's the base? 8 into height. QN is equal to 80. So QN is equal to 80 by 8, which is equal to 10. All right? Similar. AB, AD. AB is 35 and yeah. What's the area? What's the area? 1470, right? Now, if you take AB as the base into which is the altitude? DL. DL is altitude is equal to 1470. How much is AB? 35. 35 into DL is equal to 1470. So DL is equal to 1470 by 35. Okay, then again, area is equal to 1470. Base, base DA or AD into height BM is equal to 1470. How much is the AD? 49 into BN is equal to 1470. So BM is equal to 1470 divided by 40. Simplify. That's all. All right. So we've understood all that has been taught in school so far. Now you can just complete all this in your tuition class.